Hello, and welcome to lesson 2.4. So, last class, we talked about compound inequalities, and we did a very simple type of compound inequality with the x always sandwiched between two numbers, or what some people lazily call a sandwich inequality. I mentioned the compound inequality was called a compound inequality because it's the same idea as compound sentences in English, right? You can put two single inequalities together to make a compound one. And like in English, we can actually do this with two words. We're going to look at doing the words and between two inequalities, and that's different than the word or between two inequalities. So I can have two inequalities, something like x is less than or equal to 3 and x is greater than -1, and I'd like to have some sort of mathematical ability to put these together into a single statement, not two different things with an and between them. I'd like to write this finally, and my final answer as, you guessed it, once again, interval notation. Or I could do the same thing, x is less than or equal to 3, or x is greater than -1. I could do the same thing with that, and these two answers will be different. The words and or are extremely important. So, with that being said, let's talk about what the words and or mean. This is kind of mathematically and in real life how we use these things in English. So what and means, if someone says they're both, let's see, what's two good things that we could like measure? Let's say that someone says they are tall and rich. For them to be telling the truth when they use the word and, what things have to be going on? Well, they have to be tall and they have to be rich. So and must mean that both things have to be going on, right? So if someone says and, they mean both of these things are happening. So mathematically, what we're going to think is if we have these two inequalities, and means we're looking where both of them are happening, or there's a mathematical word for this called an intersection. So we're looking for the intersection of these two things. Well, that word's a bit vague. A better word that's not super mathy, but is like our everyday English is, we're looking for the overlap between these two inequalities. Okay, that's a good word. So anytime you see the word and, I want you to write or think or do something, the word overlap. So and overlap, or you can use the word both, or you can use the word intersection, but that's what and mean, is where both of these things are going on. Now let's think about the word or. Now we'll tell you that our English is a bit funny on this when compared to mathematical logic. We typically think of either or. This or the other one only means one can happen, but a mathematical or means, well, let's go through the same example. If we tell you you're tall or rich, what that means is that we're going to allow one of the two. You might be tall, you might be rich, but we're also going to allow both of them. So, pretty much, what's the best way to do this? One or the other, or both things are true. Well, this is going to be kind of weird. There is a mathematical word for this. This mathematical word is called a union. That's the same idea as the mathematical word called an intersection. A union. What that means is we're just going to stick these two ideas together, and if you fit anywhere in there, that's fine. If you're in the tall people section, or in the rich people section, or in the overlap of tall and rich people. Okay? So one kind of idea is just to stick these together, or combine these together, or smush both of these areas or these regions together. This will make much more sense when we do examples with inequalities than with qualities like tall and rich. But actually, we could do a Venn diagram from like third grade to show you what these mean. So here's the circle of all the tall people, and here's a circle of all the rich people. If I'm doing and, that means the only people that I'm talking about are the people in both circles, which is where the overlap or the intersection happens. If I'm doing or, circle with all the tall people, circle with all the rich people. If I'm doing or, that means it could be in the rich circle. Okay, my coloring's not that good. I might have to go back and redo kindergarten. Or it could be in the tall circle, or it could be in both circles. So notice how we just take everything out of either category. Both categories is included in our answer. All of it. We just did what's called a union, which just means to add them together. So we took all the tall people, all the rich people, and we just added their circles together and said, yeah, the more the merrier. So I like to think of these and as being really selective or really exclusive. So to get into the and club, it's really limiting. Only the sliver in between both of these circles. Or is very welcoming. Everybody can make it into the or club. If you just happen to be in the tall conversation or happen to be in the rich conversation, come on in. It doesn't matter if you're in one, the other, or both. And that's what or means. Okay? This will make a lot more sense when we do examples, but I wanted to give you some background on the words and and or. So let's see, how are we going to do this? We're going to use something called the 3-line method. And you guessed it, to do the 3-line, I'm going to do 3 number lines. So let's actually show this with an example. So our first example is one I've already written. X is less than or equal to 3, and X is greater than -1. So to do this, I'm going to need 3 number lines. And for this to work, I'm going to want to line these number lines up. So I know on one of the number lines, so the top 2 lines of this 3-line method are for comparing x to 3. The second line is for comparing x to -1, and the third line is for our answer. So I know I'm going to want a 3 on here somewhere. I know I'm going to want a -1 on here somewhere, and I would like to line it up. So instead of taking the time to draw 3, 3, 3, -1, -1, -1, we're going to be lazy and just say, okay, all of these, yes, that is 3. All of these, yes, that is -1. So I hope you're okay with my laziness there, but that is how the notation is always done, so as not to have to include so many tick marks and so many numbers crowding this. So to use the 3-line method, it's quite simple. Top line, just start with your first inequality, or actually either inequality, but graph one of the inequalities. X is less than or equal to 3. Good news! We already know how to do this. We've been doing this for like 3 lessons now. So find 3 on this number line, and less than 3, x is less than 3 would be this direction. Beautiful. Now what symbol goes here on the 3? It's an or equal to, so that would be a square bracket. Nice. Feeling good? All right, let's take the other inequality. X is greater than -1. So find -1 on this number line. Here it is. And greater than would be shading this way. And it is a plain greater than, so that would be a parenthesis. All right, I'm feeling really good because we already knew how to do these top 2 lines, just graphing 2 inequalities. So the whole point of when I stick this word in between here is to make a compound inequality where I consider these together with the word. And so what I do is when I teach this, what I find is the people that miss these just pay 0 attention to the word. They don't pay full attention to it and do whatever they want for some reason. So I want to require you to go ahead and write the word over again, so you have to pay attention to it. So this is our answer line, and our word is and. So I made myself write it. Now think back to the last page. What did and mean? It meant overlap, or where both of these are. So if I could literally squish these 2 lines together, which I can using this software. So let's pretend I pick up the green line and move it down, squish them together. Is there anywhere that you see both green and blue? And your answer is yeah, right here in the middle section. Let me move it back up now. So where does the blue and green graphs overlap? Well, you look, with these tick marks here, we've naturally kind of created 3 sections to check. Do I have blue and green overlapped on the left? No. Do I have blue and green in the middle? Yes. Do I have blue and green on the right? No. Okay then. So the place where the green graph and the red graph, what color is that? Blue graph overlap is in the middle. So that means that is my answer region. So I'm going to shade that down below because the third line is our answer line. Now, anywhere you start or stop shading, you need to grab the symbol from above. And so let's see, I stopped or started at a -1 and I used a parenthesis there. I started or stopped at a 3 and I used a square bracket up above. So there's our answer line. Now, relying on a skill that we've had for the last 3 lessons or so, can I read off this bottom answer line and write interval notation? You bet you, because we read it from left to right, and you tell me where we started shading at -1, comma, where do we end shading at 3? And grab the symbols, parenthesis on the -1, square bracket on the 3. Nice. So, the 3-line method just gives us a logical way to do this and group these together. All right, was that super duper hard? Hopefully not. What if I wanted to do this with an or instead of an and? So let's do the same inequalities, less than or equal to 3, or x is greater than -1. And here you should be able to see what I mean when I talked about one being very exclusive, very strict to get in the club for our answers, and one being very welcoming. We're still comparing to -1 and 3. Be careful not to write your numbers in the wrong order because this is a number line, so smaller numbers need to go on the left, larger numbers on the right. All right, and let's do this again. You already know how to do the top 2 lines. You just graph these. X is less than or equal to 3. So find 3, that's a square bracket, less than's to the left. Let's graph x is greater than -1, so find -1, that's a parenthesis, greater than's to the right. All right, now draw full attention to the word. This is an or. An or is welcoming. So let's ask ourselves a question. Instead of saying, so we have 3 regions. Instead of asking, do I have blue and green? I'm asking, do I have blue or green over in this left region? You say, yeah. Well, then that must be in my answer. Do I have blue or green in the middle? Yeah, I have both. Well, then that must be in my answer. Do I have blue or green in the right region? Yeah, I have blue. So that must be in my answer, because or is welcoming. Anywhere that you have shading up top comes down to your answer. If you have one color, the other color, or both colors, if you have one bit of shading or both shading, or the other shading, it all comes down to your answer. So wow, this was really welcoming. We have the whole number line. As a matter of fact, if I tried to write interval notation, I start at the arrow and I end at the arrow. I start at -infinity and I go to positive infinity as my answer. This is all the numbers, the whole number line. Wow. So the same inequalities, less than or equal to 3, greater than -1, but with different words is drastically different. So this one's really restrictive. It only gets the overlap. This one's really welcoming. Anywhere there's graphing is in my answer. Okay, well, let's look what happens if I have these pointed in different directions. These are both pointed in. Let's look what happens when they're pointed out or pointed the same direction. So a few more examples, okay? And we'll do and or for all the rest of these. Okay, so let's do another example. Let's do x is greater than or equal to 1 and x is greater than 4. So this time the inequalities are both greater thans. They're going to be pointing in the same direction instead of pointing into each other. And I need to compare x to the number 1 and the number 4. And we'll do the same thing. So our first inequality, we'll graph that on the top line. X is greater than or equal to 1. I think I got it. Our second inequality, we'll do that on the second line. X is greater than 4. I think I have that. Parenthesis to the right. And then we'll do our answer line. And let's pay attention to the word. I'm doing an and. So write and down. And means overlap. So do I have blue and green over on the left overlapping? No. Do I have blue and green in the middle region? No, just green. Do I have blue and green in the right? Yeah, I have blue and green. So this must be what's shaded in my answer. Now I started or stopped at 4, so grab any symbols above a parenthesis. So my interval notation here says I'm going from 4 to infinity. Okay. All right, well that was interesting. What if I wanted to do, notice once again that the and is pretty strict on who gets in the club. Let's compare that again. We'll use the same inequalities, greater than or equal to 1, or x is greater than 4. So we're going to use an or this time to compare the and the or. And once again, I'm comparing x to 1 and to 4. And to spare you the boredom, I'll try to go quickly over the top two graphs. We just did this. Greater than or equal to 1. X is greater than 4. All right, nice. So now let's get ready to do the answer. I need to pay attention to the word. What's the word? It is or. And or means if I have green, if I have blue, or if I have both, it will be in my answer. So let's check the three regions. Do I have blue or green over here on the left? No, I have nothing shaded on the left. In the middle, do I have blue or green? Yes, I do. That'll be in my answer. In the right, do I have blue or green? Yeah, I have both. That'll be in my answer. Oop, I started or stopped at 1, so let me grab the symbol. Okay, so remember, one way I described or was anywhere you had shading above comes down to the answer. And so this is much bigger than this region. This is much more in welcoming. It says, hey, anywhere I have shading, come on and join the club. I have 1 to infinity with a square bracket because that was what was on this the graphs. Nice. Okay, well, let's do one more example of each, an and an or, and then I think you'll have this all the way down. You'll have seen all 6 combinations of things that can happen. All right, and we might get some weird ones with this next one. Okay, so let's see, what do I have left for examples? Let's go with, I'll do and then or. Let's go with x is less than 3 and x is greater than 4. And we'll do our 3 lines for our 3-line method. I'm comparing x to just 2 numbers. Let me put them in the right spots, 3 and 4. And you know the drill. You know how to graph the top line using the first inequality, which is a skill we've had now for 3 lessons or so. X is less than 3. Find the 3. Less than 3 is to the left. Let's graph the second inequality. X is greater than 4. Find the 4 on the second line and go greater than. That's to the right. And then let's pay attention to the word. It's an and. Make you write the word and over. And meant overlap, or both. Do I have blue and green both in the left region? No, just green. So it's not in my answer. Do I have blue and green overlapping or both in the middle? No, I have neither, so it's not in my answer. Do I have blue and green on the right? No, I just have blue, so it's not in my answer. There is nowhere where green and blue overlap, so there is nothing that comes down to my answer. Actually, this is just there is no solution. It is the empty set, and you can write that as a 0 with a slash through it. Okay, or you can write out no solution. And is so strict, it did not let anybody in the club. Okay? Like I said, and is strict. Now watch what happens when we do or with this one. So I'm going to use the same inequalities and use the word or instead of and. And didn't let anybody in the club, but or probably will. So we'll graph the same ones. I'll try to go really quickly because it's identical to the top 2 lines here. X is less than 3, got it. X is greater than 4, got it. I probably should have done that in blue to keep things consistent. There, that'll do, right? And then let's do our answer. So or, let's write that down. Or means anywhere I've shaded up top comes down. Or if I have green, or if I have blue, or if I have both, it comes down. So look over here in the left region. Yep, I got some green. It's going to come down. I don't have anything in the middle, but I do have some more on the right side. Okay, anywhere you start or stop shading, still the symbols. So at the edges, it's always arrows. This 3 had a parenthesis, this 4 had a parenthesis. So this is my weird answer region. That is kind of weird. And I have 2 different chunks. Well, I can't write that interval notation as one interval. I have an interval here, and I have an interval here. So what do? Let's write them each with a little space between them so that we can put an official symbol between them here in a second, okay? So what's this first interval? It's from negative infinity to 3. So let's write that one. Negative infinity to 3, parenthesis. Leave a little space. The next one is from 4 to infinity. 4 to infinity. Now, I told you what or officially is called as a union. You actually put a union symbol, which means kind of together. Like they call it like when you get married, like a union of two people. We're marrying these two things together. And what a union symbol is, the mathematical symbol is actually called a cup. It looks like a capital U with no tail. So there, a big union symbol. And that is my final answer. So the best I can do for writing it as a single interval notation is two married together with a union symbol. Okay? So now you've seen kind of all 6 things that can happen. You've seen and or for when they're pointed in towards each other, and or for when they're both pointed the same direction, and or for when they're pointed out. And so with this lesson and last lesson on compound inequalities, we can handle any idea of compound inequalities now. We can handle simple sandwich ones where x is just stuck between, but we could also handle putting any two together with the words and or, kind of like making sentences with and or and buts and all that stuff. Okay, so that's pretty awesome. That's all I have for you to now. I'll see you next time.